Let's first focus on 3 examples where the absolute value is less than or equal to a number. Let's look at the absolute value of x less than 3. Recall that the absolute value represents a distance from 0 on the number line. In our example, the absolute value of x is less than 3, which means the distance from 0 is also less than 3. So that's exactly the case when the value of x is between -3 and 3. How can we represent this on the number line? We have to plot all values of x between -3 and 3. And must use parentheses because -3 and 3 are not included in the solution set. How can we represent this solution in interval notation? The interval goes from -3 to 3. The solution set is a set of all x such that x is greater than -3 and less than 3. Let's look at the absolute value of 3 minus 2x is less than or equal to. The expression 3 minus 2x between the absolute value bars has to be between the negative of the number on the right side and the positive of the number on the right side. That's exactly what we did in our previous example. The goal is to isolate the x, so subtracting 3 on every term leads us to -5 is less than or equal to -2x is less than or equal to -1. Dividing all terms by -2 leads us to 5/2 is greater than or equal to x is greater than or equal to 1/2. Remember that dividing inequalities with a negative number flips the sign. Now, let's plot the solution set on the number line. And use brackets. Because 1/2 and 5/2 are included in the solution set. The interval notation goes from 1/2 to 5/2. So we're also using brackets here. And the solution set is the set of all x such that x is greater than or equal to 1/2 and less than or equal to 5/2. Let's do one more example where the absolute value is less than a number. -7 plus 2 times the absolute value of 2x plus 1 is less than -1. In this example, we have numbers outside the absolute value on the left. Always isolate the absolute value first before you start. If you remember, in the previous examples, the absolute values were always by themselves. So let's add 7 on both sides. And we get 2 times the absolute value of 2x plus 1 is less than 6. Dividing on 2 on both sides leads us to the absolute value of 2x plus 1 is less than 3. Now, the absolute value is isolated on the left side, and on the right side we have a number. So we know now from our previous examples that 2x plus 1 is between -3 and 3. Subtracting 1 from this compound inequality leads us to -4 is less than 2x is less than 2. -4 divided by 2 is -2. 2x divided by 2 is x, and 2 divided by 2 is 1. Let's plot this on the number line. The interval goes from -2 to 1. And the solution set is the set of all x such that x is greater than -2 and less than 1. Let's look at an absolute value inequality where the absolute value is greater than a number. The absolute value of x is greater than 3. When the absolute value is greater than 3, the distance from 0 on the number line is greater than 3. So the value of x can be all numbers which are greater than 3 or less than -3. Because the distance of all these numbers from 0 are greater than 3. So the interval notation is -infinity to -3 union 3 to infinity. And the solution set is the set of all x such that x is less than -3 or greater than 3. Let's look at the absolute value of 1 over 2x minus 1 over 3 is greater than 1. The expression 1 over 2x minus 1 over 3 is greater than 1, or 1 over 2x minus 1 over 3 is less than -1. Adding 1 over 3 on both sides leads us to 1 over 2x is greater than 4 over 3. dividing by 1 over 2 on both sides, which is the same as multiplying by 2. Leads us to x is greater than 8 over 3. Now let's look at the other inequality. Adding 1 over 3 on both sides leads us to 1 over 2x is less than negative 2 over 3. Dividing by 1 over 2 leads us to x is less than negative 4 over 3. How do we plot this on the number line? X is greater than 8 over 3. Do we need a parenthesis or a bracket? Since x is greater than and not greater than or equal, we need a parenthesis. And because it's greater than, we need to plot the right side. The other answer is x is less than negative 4 over 3. So we have to plot the left side. The interval notation is negative infinity to negative 4 over 3 union 8 over 3 to infinity. And the solution set is the set of all x such that x is greater than 8 over 3 or x is less than negative 4 over 3. Let's look at our last example. The absolute value of x plus 7 is greater than negative 1. The expression x plus 7 is greater than negative 1, or x plus 7 is less than 1. Subtracting 7 on both sides leads us to x is greater than negative 8. Also here, subtracting 7 on both sides leads us to x is less than negative 6. Let's plot this on the number line. X is less than negative 6, so let's plot on the left side. And x is greater than negative 8, so plot this solution on the right side. The interval notation is negative infinity to negative 6 union negative 8 to infinity. In contrast to the previous two examples, in this example we don't have a gap. So our solution set includes all real numbers. The set of all x such that x is an element of the real numbers. If you have any questions, feel free to ask me in the comments. This video is what I did for you. If you want to do something for me, hit the bell button, share and subscribe. Thanks for watching and happy learning, everyone.